Hello everyone, so in this video let us talk about an easy problem from LeetCode. The problem name is Goat Latin. So let's read the problem statement. It states that you are given a sentence which consists of different words separated by spaces. Fine. Each word consisting of lowercase as well as uppercase characters. Now there are certain conditions so that you have to convert the sentence to Goat Latin. Now what are the given rules? The rules are such that if the word, whatever word you have in the sentence, starts with a vowel E, I, O, U, append MA to the end of the word. So let's say if the word is, let's say, apple, which is like starting with A, that is a vowel, you'll append MA at the end of this word. Secondly, if the word begins with a consonant which is not a vowel, remove the first letter and append to the end and then add MA. So if it is, let's say, goat, you will take this first character, that is G, put it in the end, so it is OATG, and then append MA again. Similarly, the next thing is that add one letter A to the end of each word as per its word index, which means that let's say the first character, like first word, will be appended one extra A. The next word will be appended two extra A's, and so on. So let us see the example so that it will become more clear to you. So you have to just output the output final strings, what you have to have, like what is the actual sentence converted into Goat Latin. So I is there, so this is a vowel you say, and then you append MA to it, and then because it's the first word you append one more extra A. Now it is speak, so speak is starting with a consonant, so take this S, put it in the back of K, so it is PAKS, and then put MA, and then because it's a second word, append two more A's, then three more A's, and four more A's, and accordingly we'll do these like convert this whole sentence. So that's the whole problem. Now you can pause this video, try to think over that, but it's very simple. What you can do is you have to first extract out each word from this whole sentence, and then try to convert it to Goat Latin and then make the new sentence. Now how to extract out every word? It is a very standard thing. So let's say that you have a string, let's say you can say okay, then this is some space, I'm just giving some space, let's say it's some space, then fine, space, it is done. So now what you can see is that what you can do is to actually take out words from this. You can start from this particular character at the first character, and you can take some empty string which is the character that you are currently on. So let's say current. Now if you are on a particular character, just keep on appending that character in current. So it is first is O, next is K, and whenever you see a space, you know that now this is a space, so whatever characters I have accumulated is a current word, so that is okay. So now you again start afresh from the next word, and then keep on appending F, I, N, E, and whenever you find a space, you know that this is one of the words. But it will cause one problem, because in the end you will keep on appending D, O, N, E, but there is no space, so you will run out of this. So you will break off this for loop, and this word will not be processed. So it's better in this scenario just append a space, like extra space in the end. So because we are terminating or finding out our words depending upon the space, so it's better just append one extra space at the end of this done, so that whenever I hit a space, this particular word is also processed. And then what we'll do in converting this to a Goat Latin, we have the word, let's say, fine. So this is starting with a consonant, so you will take this, put it in the back, so it will become INEF, and then put MA, and then because the second word you'll put two A's extra. That's it. So you will directly do that. So you will also have to store some variable that is count of what is the current count of words that you have processed. So it's the first first word, second words, and so on, so that you have to append that much A's also in the end. And that's it. That is the better information that is required. So let us see the actual code part of it. So what I've already told you is that better to bifurcate your code into small chunks which are doing their specific job, instead of writing down everything in one simple piece of code. My main point is, let's say that I want to I am iterating over this whole, let's say whole sentence, and whenever I accumulate out a particular word, I'll use this convert function to convert this word to the Goat Latin word. So instead of writing down everything in this function, I have written this convert function which will convert this from the current word to a Goat Latin, and then add this into the sentence, and then keep on appending. So I will have this current string that will keep on appending the word appending the character so that a word is formed. And we will keep on iterating over the sentence. Whenever I feel a find out an empty space, so I've inserted an empty space at the back of the string here. Whenever I find out an empty space, what I'll do, I will convert that word into the Goat Latin word and append that into the new sentence on new sentence. And then what I'll do, I'll append a space, a new space, because it is a sentence that I'm forming. Then I'll make my current equal to empty sentence, empty word, word, so that I have to now process new words after the space, and then count plus plus. Why? Because I have to also keep on incrementing the count, because we have to also add at that number of A's. So that is count is also sent in converting this particular word to Goat Latin word. And then we'll keep on doing this. If it is not a space, we will keep on appending those characters so that the current word is formed. That is the overall logic here. Now the convert function. So as you can see, similarly, now if I want to check that whether it is a vowel or not, the first character, so I can either write it down here also, but because it is just a separate function, a separate logic to check whether the first character is a vowel or not, it is not in the conversion part. Convert will only convert and use these three logics, but it will not be just checking out the vowel. So just for a particular logic, just put another function. So I've converted and taken another function that will just check that whether it is a vowel or not, the first character. So I will pass the first character, and because it is upper and lowercase, I will first convert it to a lowercase so that we have a common ground. Or either we can check it for lower and uppercase both, but what we can directly do is that, because we can directly convert that if it is even either uppercase, also convert it to lowercase and just check that whether it is a vowel. If it is a vowel, what I'll do is that I will directly append MA at the end of the word. If it is not a vowel, what I'll do, I will first append the first character at the end and then take a substring from the second character to the end. Because it is a string, okay, you have to first remove the first character as well as append it at the end. So what you can do is directly append it at the end. Now you have the first character at the first starting and the end also. Now for deleting it out, what you can do is just take the substring from the first starting from the first index. Now we have the string, and then again append MA to that particular word. Now after that, what we'll do, we will have to append certain number of A's that is equal to the count, what is the current index this word is at. That number of A's is also appended in the end of the word, and then we have the new word in the Goat Latin format. We will just send it through this function and we'll just process it in this main function that we are processing over. That's the overall logic and the code part. Now coming down to the time complexity, so this is we're iterating over this whole string, so it is O of n only. N means the length of the string here. Now this is just converting it out and appending that much of A, so it is also somewhat of O of n only, because we are then doing a for loop or number of count of A's, but it is very small in compared to the string as well, and this is a constant, just O of 1. So the total time complexity is O of n for this whole problem. So that is the overall time complexity, and the space complexity is what you can say, that we are not making a new string, we are just or actually this is a new string, storing out an answer. So you can also store that in the answer. So the string size is is also O of n, but it is a single string, so not n string, so it is O of 1 only you can take. That's overall time complexity and space complexity for this problem. Thank you for watching this video till the end. I will see you in the next one. Till I keep coding, and bye.